Hey, I'm Michelle, and I'm going to teach how to do the power rule. Okay, so the power rule is nx to the n minus 1. So if we were to find what the answer is for 5x4, 4 would be n. So you would replace 4n and be like 4 minus 1, and then bring the 4 up front. So it would be 4 times 5 to the x to the third, and the derivative of 5x to the 4 would be 20x to the third.
Alright, we're going to teach you more about the power rule. This is AP calculus. We be calculating, we be finding derivatives, we need to find logs and exponentials. If we need to find logs, use this following rule. If a function of f of x equals ln x, or f of x equals 1 over x, if we have exponential, it's basically the same, because e to the x equals e to the x. But if you have derivative of e with the functional exponent, then you treat it like it's a freaking chain rule. Then use it with the formula e to the x. Word.
Alright, so I'm James Park, and today I'm going to be teaching you guys how to use the chain rule in AP Cal. Alright, so suppose we want to find the derivative of y of x equals x squared plus 3x plus 1 squared. Well, we can always rewrite this to make it a bit more eye appealing. So let's say that u equals f of x equals x squared plus 3x plus 1, right? And then we're just going to plug this into another function called g of u, which is equal to u squared. Alright, because we're plugging the original f of x into u, we now get y of x equals x squared plus 3x plus 1 squared, or g of f of x. Alright, so here's an example of the chain rule. We're going to be using the function from earlier to find that. Alright, so we're going to take the derivative of x squared plus 3x plus 1 squared. And here we're going to have to use the chain rule. The chain rule can be thought of as taking the derivative of the outer function, which is the 2 here, and then apply it to the inner function, or multiplying it times the derivative of the inner function, which is right here. So to do this, we're going to multiply by the outer function, which is the power 2. So it's going to be 2 times x squared plus 3x plus 1. And then we're going to multiply by the derivative of the inner function, which is right there. So it's going to be 2x plus 3. And then from here on, we just simplify it out. And then we're going to get 4x cubed plus 18x squared plus 22x plus 6. And, oh, whoops.
To be teaching you guys about the product and quotient rule. So, the product rule. The following rule is the product rule. The product rule is used when you're trying to take like the derivative of a product, basically, like when you're multiplying something by something else. And this is it reads this: d dx of f of x g of x is equal to f of x g prime of x plus g of x f prime of x. Which basically means that you're taking, if you're multiplying f of x times g of x, you're taking the f of x and multiplying it by the derivative of g of x, and then you're adding g of x and the derivative of f prime of x. Since you're adding both sides to the rule, you can switch them around without a problem. Like if you want to put this one first, it's fine. A good way to remember this is by using u's and v's. So what you should do is think of the f of x as u and g of x as v. So then you can just say uv prime plus vu prime. It's easy. So you just say product rule is uv prime plus vu prime. Here's a quick example of how the product rule is used. So if I say y equals x plus 5, 3x minus 2. So y prime equals 1 plus 0, 3x minus 2, plus x plus 5, 3 plus 0. Simplifying that, it's going to be 3x minus 2 plus 3x plus 15, which ends up equaling 6 plus 15. 6x plus 15. And that's your final answer. Product. Okay. Now, for the quotient rule. The quotient rule is a little more complex than the product rule. Basically, when you're dividing something, it's when you use the quotient rule. So, f of u over v is going to equal v u prime minus u v prime over v squared. Now this is going to sound complex, but a good way to remember this, how I was taught it, was you think it of low and high. So you say low d high, which means the derivative of high. So you're taking low, multiplying by the derivative of the high, multiplying by high d low over low or low squared. So that's a really good way to remember the quotient rule, so that you know what you're talking about. Now remember, this time you're subtracting, so if you can't interchange these, it has to go in this order. Or you can put negative and then negative u v prime plus vu prime, but it's better to keep it in this order so that you don't get confused. A quick example of the quotient rule in use would be if the function reads y equals x plus 2 over 3x plus 1. So y prime, you're going to take low multiplied by the derivative of high, which is just going to be 1, and then subtract the high and multiply by the derivative of the low, which is just going to be 3, and then it's going to be over low, which is 3x plus 1 squared. Then you basically simplify. You say y prime equals 3x plus 1 minus 3x plus 6 over 3x plus 1 squared, and then the 3x cancels with the 3x, and your final answer is going to be negative 5 over y prime equals negative 5 over 3x plus 1. And that's your final answer. That's how you do the product and the quotient rule.